Alrighty, guys, let's get going. Hopefully, I get done with this video in a reasonable amount of time, but this might be a two-part video if needed. 19 questions long and whatever. Let's just go. All right. In a large Midwestern university, a simple random sample of 100 entering freshmen in 2014, blah, 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 blah. So much information here. Let P1 be this proportion, P2 is that proportion. And we're trying to figure out this 99% confidence interval. So a couple of things about this. Our general formula for all of these, we should already have in our formula sheet, but just in case we don't know it, it's going to be P1 hat minus P2 hats, and then after that, plus or minus, and it's going to be a Z star for these situations multiplied by, and now for the confidence interval, we do not use our combined one. So we're ending up with a P1 hat multiplied by 1 minus P1 hat, all divided by our N1 plus P2 hat minus 1 minus our P2 hat here divided by N2. But again, this is on our formula sheet, so you shouldn't have to write these things down again. But notice that it's not impossible just to have these memorized. You can definitely do it. A lot of the stuff you've been doing, at least bits and pieces of throughout the entire year. I fully believe in you. Also, just notice all these plus or minuses are upside down. It's minus plus. I guess it's to indicate that you do the minus for the left and the plus first. It's kind of cool. I haven't seen the minus plus upside down in quite some time. I used it in some formulas a long time ago, but I'm done talking now. So I think the hardest part of this question is going to be our Z star. To figure out our Z, and then also we have this minus sign randomly here, so we kind of know this one's wrong right away. But the Z star is always going to be using your inverse norm. That's how you find your Z star, and it's always going to be simply that your C, your area is always going to be equal to 1 minus that C percentage, and then that's in parentheses and then divided by 2, and that will always give you the correct Z star formula. What you are doing is you are finding what percentage, like visually what you're doing when you're plugging that in, is you're finding what percentage of our normal curve is going to total 99%. That is what you are doing by finding that area here. And by the way, our mean is 0 and our standard deviation is 1, our standard normal situation. I think it's a good idea to have memorized that the 1.96 is a 95% because it's going to be our most common version of it. That's, some mathematicians are dying somewhere where I wrote 1.96 is 95%, but this 1.96, a Z star of 1.96 is 95% of the area under the normal curve. So I can immediately cross off C and D, but let's just verify that 2.576 is in fact correct for our 99% using our second vars, inverse norm, our area. We have parentheses 1 minus confidence percent doesn't mean put it in the decimal form. So 0.99 divide by 2, leave everything else the same, and we can sure enough see that we get this 2.576. Again, plus or minus. I guess there was the minus pluses coming from changing that thing. But we do get the same 2.57, so that's correct. Only question is, which one of these do we do? If you notice, these ones both have 0.15 in both of them. We only do that combined concept when we are doing a hypothesis test, not a confidence interval. So our correct answer is going to be the one that has the 0.2, and that is because we have the 20 over 100 for the first sample, and you have the 10 over 100 for the second sample. So that's where the 20 out of 100, 0.2 is the 20. So maybe I should write that somewhere, like P1 hat is equal to 20 over 100, which is 0.2, and P2 hat is equal to 10 over 100, which is 0.1, and 1 minus 0.2 is 0.8, so on and so forth. Regardless, whatever. Answer is letter D. Let's move on. We already spent 4 minutes on the first question. This is not going at the speed I wanted. Life goes on. This one here is the same exact question, but we don't actually need to use the formula because we have a beautiful calculator that's going to do all the work for us. This is going to be calc, please. And calculate anytime you're doing a proportion. This is called a two-sample Z confidence interval. I think it's called that in the calculator anyways. I guess we're going to find out if I have to erase and do stuff. My bad if you wrote that down already, but we're going stat. Tests. And then we're scrolling down to 2 sample Z interval. So it's called a 2 samp Z int. Is it? Or is it 2 proportion Z int? Oh, 4 proportions. 4 population proportions, I should have said. Technically, you could do the Z interval one, but it would be extra work for you because you'd have to calculate the standard deviation separately, which would not be fun. So 2 sample Z confidence for population proportion. So some people would say 2 proportion Z confidence interval. That would probably be better. Maybe I should rewrite that actually. So 2 proportion, 2 prop Z int, and maybe this one really should be the word proportion. Just to make sure you're being careful on like the free response section of the test. Regardless, on this one, you just have to type in all of the numbers as they appear. So our x1 on this one was in fact the 64 out of 100. So we have 64. Our n1 is therefore 100. Our x2 on this question is going to be 80, and our n2 is also 100. And then we just throw all of it into our calculator. So we got 64, we got 100, we got to 80, we got to 100, and then 95% confidence. All right. And again, we could have used the formula from the question above, but why if we can just do the work, right here. So we're looking at negative 0.2825 to negative this one, letter E. Boom. Move on to the next one. Number 3. Your teacher claims to produce random numbers from 1 to 5, inclusive, so it includes the 1 and the 5. On her calculator, you kept track of the results. In the past 80 rolls, number 5 has only come up 8 times, so 10%. It's, unlikely, but not unreasonable. You suspect the calculator is producing fewer 5s than it should. It's not that bad. All right, let P equal a true proportion of 5s. Which of the following hypotheses could be used? All right, so first of all, never, ever, 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 ever use a P hat in these problems or your X bars. You want to make sure you're using population values in your hypotheses test. So has to be a population value. After that, we are also going to be assuming that it equals the 0.2. So all these are great. After that, we are going to be seeing which one is it. You suspect it's producing fewer. So fewer is less than. So less than, letter C. Moving on to the next one. Oh, it's flipped upside down. Okay. Okay. University, blah, 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 blah. We have a p-value of 0.28. All right. So before I even read the answers, if you have a p-value of 0.28, you fail to reject the null hypothesis. There is no reason to believe that there's a difference between whatever this is. So it's random sample in the mean for male and female scholarship athletes. So there's no reason to believe that there's a difference. Which one of them hasn't? The GPAs are identical. That is not true. They're not identical. All right, the maximum, no, that's silly. In fact, there is no difference. There's a 0.28% probability of getting a difference in GPAs between. That is a true statement. That is what a p-value is. I'm going to go ahead and see if that's the correct answer. The chance of having a randomly chosen male, no, there's no probabilities on that one. There's no chance of a randomly chosen one. It's like all of them. Probably fit, no. Okay, so this is letter C is our correct answer. This is what a p-value is. P-value says you are assuming that the two things are true or whatever the null hypothesis is, and it's the probability of arriving at the results that we did arrive at, assuming the original is true. So yeah, letter C is what we want. All right. A buyer for a grocery chain inspects large truckloads of apples to determine the proportion P apples In the shipment that are rotten, she will only accept the shipment if there's clear evidence that this proportion is less than 0.06. She selects a random sample to test these hypotheses. Nice hypotheses. Sample contained 9 rotten apples. Which of the following intervals contains the p-value for this test? So we can find p-values quite easily on our calculator. So p-value from calc. And we're going to go ahead and use our stat. And then we're going to go to tests. And then we need to figure out which test we're running, right? So on this one, we have only a single sample. And we're taking our one sample of a proportion. And we're running a test on it. So this is a 1 proportion Z. I really hope I typed it in right this time. All right, let's see. Or I typed it in. I wrote it down. That's typing it in modern days, right? There it is, our 1 proportion Z test. I did it perfect the first time. All right, so we have the 0.4. Our assumed value is 0.06. That's from right here. There's our assumed value, 0.06. Our X in this question is 9. Our N is 20,000. Yeah, we got to calculate what our I was supposed to write down a bunch of these things. P naught was 0.06. Our X was 9. Our N was 20,000. And we are doing a less than P naught situation because we have a less than right there. Okay. Anyway, so that was the part I didn't even select on my calculator. So now I selected that less than P naught. And now I'm going to go ahead and calculate it. And we can see that our Z value is negative 35. We got a 35 sigma situation here. Yeah, P value is effectively 0. So that's basically, yeah, it's a 0. It actually says P value of 0. It can't be actually 0, but it's very, very close to 0. So it is way less than 0.01. It is 0, 0. Yeah. All right. Anyways, significance test was performed to test this. Oh, by the way, and it means she's going to accept the thing because it's less than 0.06. All right. The significance test was performed to do this. Its Z test is 1.4. Which of the following is closest to the p-value for this test? So remember that the whole point of doing these test statistics is you're going back to our original p-value situation. Anytime we have a greater than symbol, we're just going to be doing greater than. Less than would be a less than side. A not equal to would be a double sided both sides. So it's really saying we have this 1.4, and we can do this by doing a normal CDF. A normal CDF will get through this exact situation for us. So we're going to go ahead and quit out of this. We have, oops, stat, no, not test, vars, normal CDF. And our lower is 1.4, our upper is 99999, and we can leave our standard deviation alone. Maybe I should write that down for you. Lower 1.4, upper 999, and mu is 0. Standard deviation is 1. That's our standard normal table. And we paste it up, and we hit it up, and we got 8%, 0.08 for our p-value. P-value. Number 7, medical experiment. 5-hour energy. I love my 5-hour energies. You guys will probably tell. I do like them. Probably addicted to them, to be honest. I have 1 or 2 a week at least. All right. The study used 50 different response variables associated with the energy, such as general health, amount of sleep, focus, etc. The subjects were 40 women between 25 and 40 years of age. Close enough, right? At the end of the study, the 5-hour energy group displayed significantly better responses at the 0.05 level for 3 of the 50 response variables studied. Okay, I'm about to go on a rant right here. This is exactly the type of experiment that is the problem with like modern news segments. So they'll do like one thing and they're going to test it for a bunch of different stuff, and they're like, hey, these 3 things it worked out for, when it could have just happened by random chance. So I really hope one of these things says throw all these out and replicate them, because this is crap. Bad. No. I like letter D. I really like letter E. Hold up. That better be the answer in the back. I'm checking the answer right now. Where's my answer key? It's somewhere over here. The answer had better be letter E. Otherwise, I'm mad at this book. Where's my answer key? Normally, I pause the video, but I'm so upset that... Oh, look, it better be E. Where is this key? Why am I struggling? There it is. What problem are we on? Number 7? Oh, thank goodness they put E as our answer. Very good. All right. I was gonna be pretty angry if it wasn't. I gotta admit. Like, anyways, point is, if somebody tells you they studied 80 different things and these three things are what's healthy, they're lying to you. Although I do like my 5-hour energy. I don't think I don't think they're healthy though. Let me tell you that much. All right, number 8. Let's go. An SRS of 45 male employees at a large company found 36% of the company was supportive of female employees. Okay. An independent simple random sample of 40 employees found that 24 felt, and we want to see if there's a difference, right? So, 24 of the 40 versus 36 of the 45. Is there a significant difference? Which of the following is the correct test statistic? So this one is, again, on our formula sheet, so I don't necessarily need to write it down, but I want to prove to you that it's possible to memorize these. You don't need to be, doesn't need to be perfect in order to do it. Our Z value is always going to be equal to P1 hat minus P2 hat. Minus, and it's almost always minus 0, which is why there's none of them have an extra minus sign on it on these ones. And then after that, our big huge square roots is P hat C 1 minus P hat C all divided by N1 plus P hat C times 1 minus P hat C all divided by N2. However, please note that the AP test actually factors out the PC 1 minus PC, and they they don't write it like that. I like to write it like this because it reminds me it's just like the other one, except it has the PC instead of the P1. But when they write it on the exam, they write it like this, where they factor out that 1 minus PC hat. They're a little bit better on the mathematician nerdiness there. You know, they wrote the PC minus 1 minus PC one less time, maximize that laziness. I kind of am sympathetic, but also the way up here is the way that I learned it, so that's kind of what I'm going to have memorized. Regardless, on both of these, the PC hat is the x1 plus x2 divided by n1 plus n2. You quite literally add the fractions the way that you're told not to add fractions as a little kid. So you're adding the numerators together, add the denominators together, and that's your PC. And in fact, that's kind of the only thing you really need to do on this one, kind of all by itself. So we have our x1 is 36, and this one is 40. So we have 36 plus 40 divided by our 45 plus 40 on, no, 45 and 24, right? Yeah, 45 and 24. And that's going to be, oh, you can't even read what I'm writing. My bad. 76 over... Oh, what did I do? I did something really wrong. Oh, I put the 40 and the 20. Maybe I should stop working today. I don't know. There you go. 36 plus, and it's 24 because we're doing the number of successes. So we had 36 successes, we had 24 successes over the sample sizes, which were 45 original and 40 original. There we go. Now we're talking. 36 plus 24 is in fact 60. The bottom part of this is 95. Which I suppose they decimalize in these questions, and I should probably just 36 plus 24. Okay, 45 plus 4. Why did I type that in? That's embarrassing. Did I really? Guys, I'm going crazy. I'm officially going nuts. I did 45 plus 40 and I got 95. This is disastrous. This is a disaster. 706. Okay, there's our 706. I guess we could have figured that out, surmised it ourselves. What's the difference between these ones? I actually can't tell. Aren't they exactly the... What am I missing? I'm going to pause it. I can't tell the difference between B and C. I actually don't think there's a difference. If someone can see a difference, maybe this is a sign for me to pause, but I don't know. I legitimately can't see a difference between these two things. I think they are the same. Maybe somebody smarter than me can see something a little bit different, but they're both correct. Oh yes, they are both correct. Beautiful. Love this test. I wonder what the answer key says on this one. We didn't check that one, did we? Can we check this one? Here we go. It says that B is correct, not C, even though difficulty easy my butt. Difficulty easy. Okay. What's the difference? I really can't see it, guys. I don't see one. Maybe somebody can point it out to me tomorrow. There's a minus sign or a plus sign difference somewhere I'm not noticing. Whatever. We're doing number 9. A researcher wants to see if kelp extract prevents frost damage on tomato plants. 100 blah. I can't even read it. What is the p-value of this test? All right. So doing a p-value of a test, yet again, we want to run our calculator. So this is, again, calculator. I think it's actually exactly the same one as our previous one, right? Are same like buttons? Is it the same buttons? No, it's not. It's not the same buttons. This is a 2 proportion Z test. 2 prop Z. 2 prop Z. We got 2 proportions, so 2 prop Z test for sure. And when you do that, it's going to ask you a whole bunch of things about X1, N1, all that kind of stuff. So our X1 in this one goes with P1. Let P be the variety that would experience damage under kelp. And this is the damage under no kelp. So group 1 is kelp. 12 out of the 50. X2. Pausing for a second. All right, here we go. We're going to keep going. We're continuing on. Our X2 here is equal to 18. N2 is still equal to 50. And we want to see the 2 prop Z test on our calculator. So we got stat tests 2 prop Z, and our N1 12, N2 50, X2 8, N2 50, not 8, 18, less than, we're on the right one already, and calculate. Looks like our p-value is 0.095. All right, so our p-value is 0.095, so letter B. There you go. Okay. Moving on, question number 9. The weights of 9 men have this mean and a standard deviation. This standard error of the mean. Standard error of the mean is equivalent to the standard deviation of the sampling distribution. So SE of our X bar here is equal to our standard deviation of our of this in the vast majority of situations. The big difference is it is really close. The only thing is I'm going to pause this really quick. I'm like 95% certain the standard error one has as an n-1, but they're not actually exactly equal. Why did I say that? I'm pausing. And the answer is nope. They actually have exactly the same thing. They're exactly equal. I don't even know why I wrote this close thing. Standard error is exactly equal to the original of the standard sampling distribution. I like second guess myself for absolutely no reason. They are equal to each other. Regardless, when you're doing these questions, all you have to do, the very, very simple formula, which you probably already remembered from the previous situation, is the same thing as the original standard deviation. Oh my gosh, you cannot read my handwriting. The original standard deviation divided by the square root of the sample size, or in this situation, 15 divided by the square root of 9, which is 15 over 3, which is 5. Okay. Mr. Richards, get it together. Get it together on this next question. We are having mistakes upon mistakes. Question number 11. All right. 2 independent random samples of N1 equals 15 and 2 75 are drawn for population 1, population 2. In order for T procedures to be valid, what must the sample size of each population be? Times 10. Times 10. The 10% condition, which is the same exact thing as the independence condition, is multiply by 10. That's it. So 500 and 750. 500, 750 done. And by the way, it does have to be over 30 still, unless you can assume normality for another reason. All right. Anyways, whatever. All right, number 12. An advertising firm is comparing these two different things using technology. What is the 98% confidence interval? So this one here, I skipped all the stuff, and that's actually totally fine on the AP test. Great thing to get used to. If you just need to figure out what a 98% confidence interval is, this is a 2 sample t. Anytime you have a mu minus an average, that is going to be a t-test, unless you can assume the standard deviation of the population in advance, in which case use a z, but that's never actually on the AP test. Okay, let's move on to our buttons. Tests, 2 sample t right there, number 4. And we are entering in statistics, and we are literally just entering in these things as they appear. This is kind of straightforward. I don't think I need to write down exactly what things. You're just using the numbers from the table up here. So our x1 average is 6.1. Our standard deviation of the first one is 1.7, and the ends are both 24. And then our second one is 4.8 and 1.3, and again with a 24. Never ever select the pooled button, and you are checking. This is not a test. This is a confidence interval. You know. What am I doing? 2 sample t interval. Okay. Oh, it saved it. How nice of them. They knew I was going to do this. 98% confidence interval. All right, there we go. Look at us. We did it, guys. 0.24, 2.3, 0.24, 2.3. They don't even have the correct answer on the sheet. We'll go with letter C, close enough. All right, number 13. Oh, by the way, the reason why is because the calculator is using the degrees of freedom. That is the calculated 43. I'm imagining what they're doing on this is they're using the quote-unquote conservative degrees of freedom, which will be the smallest of these ones. Like if I fix the degrees of freedom to be 23, I imagine I would get this slightly bigger answer there. Actually, that's even more exact. I wonder what they do different. Is there 24 afterwards, estimates, blah, 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 blah. No indication on normality. Maybe they just have like literally the wrong answer. I don't know. Maybe I typed something in wrong. 6.1, 4.8, 1.7, 1.3. They're both 24. Whatever, I'm giving myself a gold star. Moving on to number 13. Do students tend to improve their mathematics the second time they take a test? I don't know. Let's find out. First score 450, so he went down. He went up. Stayed the same and up. All right. Assume which of the following is the correct 90% confidence interval for mu. So you're allowed to approximately normally distributed. So we are going to be doing the difference of these two. This is the same person twice. So we're going to create an extra list here. And that's the one we're actually have to type in a list into our calculator in this one. Kind of fun. All right, so 450 minus 440. Yeah, we're gonna do second minus first. So actually 440 minus 450. This one is going to be -10, and the second minus the first. So 80 minus 10, 80. I'm doing 440. Like this one minus this one, this one minus this one, this one minus this one, 0. This one minus this one, and 30. So we need to create our confidence interval for this situation, 90% in this case. So we're going to be doing the same exact thing as a regular t confidence interval, number 8, the t interval, but we need to input data. And the problem is we don't have any data in our list right now. So I told you to do all these things, and then you haven't put them into a list. So let's put these into list 1. So we're going to quit out. We're going to put them into a list. Edit our list. Put them into our list 1. We got -10. We got 80. We got 0. We got 30. We're going to quit out. We're going to go ahead, and now we're able to run our interval. All right. And sea level is 90. By the way, you could actually do stats if you went and calculated you calculated the mean and the standard deviation of these. Instead, you could do it that way, but it's kind of a waste of time. Invalid dimension. Do I have nonsense in my list somewhere? I probably do. Oh, because this is list 3. My list 1 has disappeared. I must have made a mistake way earlier in my lifetime messing with this. So we're going to t-interval list 3. Okay, so -22 to 72.5, but we do need to figure out what the middle is. So let's write these numbers down. So we have -22.56 to 72.555. 5. Okay, you can't read my handwriting. Totally fine. We're gonna take those two numbers and we're gonna need to figure out the middle. I guess the middle is quote unquote obviously 25, right? You can figure out the middle by adding them up and dividing by 2. So I did 72.555 plus -22.56, and I add those up and then click divide by 2, I'll get 25, or very close to it. However, if I subtract the 2 instead and then divide by 2, I will find the margin of error. So the margin of error is 47 in this case, and that's exactly what we wanted. By the way, another way of finding the margin of error, if you didn't want to change that to subtraction, what you could do is to find that middle value and then subtract one of the edges. So I just do 72.555 and subtract the middle, and we'll get the same 47.56 as we did before. So I guess I can show the work for it. The middle, which is our point estimate, our x bar here is going to be 72.555 plus -22.56 divided by 2. And our margin of error is the same exact thing except with a minus sign. 555 minus the -22.56 all over 2. Or margin of error is equal to our x bar minus either end. Okay. Which of the following is not required for hypothesis mu? Glancing at it, n times p. That one is for p's only, not for this situation. Okay. There we go. Number 15. Let's keep the ball rolling here. In a hypothesis test, this one's we got a two-sided test here. P-value of this one, which is true. So p-value here, p equal 0.08 is greater than the 0.05, which is alpha. So we fail to reject. Anytime your p-value is greater than alpha, fail to reject. There's no reason to believe that it's different than 100. Which one is this? There's insufficient evidence to conclude that it's not equal to. Boom. That's all there is. By the way, there's never sufficient evidence that the mean is 100, just that there's insufficient that it's not. So letters B and D sound similar, but D is the correct one. B is not the correct answer. Be careful with your reasoning. All right, an ecologist thing, blah, blah, blah. Which of these is our standardized test statistic? So do want to make sure that we're aware of this one, but our T formula, again, it's on our formula sheet, but it's exactly the same really as our other proportion one. So here we're going to be doing x bar 1 minus x bar 2 in parentheses minus, and this is usually 0, not 0 if assumption is different. Assumption is Like this right here is usually 0, but it's technically mu1 minus mu2. It's just that assuming that mu1 and mu2 are in fact both 0. So not 0 if the assumption is mu1 minus mu2 equals SDN for some dumb number. Regardless, dividing by the square root here is going to be easier. It's just like the previous one. You have a square root over a sample size, but this one's going to look like this. S1 squared over N1 plus S2 squared over N2. So which one is that? Well, let's go figure it out. So we are trying to do mean weights are in fact equal. So it looks like we did the sheep minus pig. So sheep minus pig, beautiful. So the top is correct on all of them. Just glancing at what it looks like A is obviously wrong. It looks like D is obviously wrong. It looks like E is obviously wrong because they don't even have the correct format. It doesn't even look like this. And then these ones are missing the squareds. So letter C is our only correct answer. I don't think it's going to be that easy on the actual AP test, but you never know. I mean, that one kind of just lines up nice and neat. That's the only one that even looks like the formula, so you need to really look for the numbers. All right, I'm moving on. Next one. We got number 17. Oh, we're done with the multiple choice. We almost there, guys. All right. All of us non-smokers can rejoice. Rejoice! The mosaic tobacco virus that affects and injures tobacco plants is spreading. I don't know. I don't know if I'm rejoicing that everyone's going to be depressed because they don't have their whatever, their death sticks. Meanwhile, tobacco company is investigating if a new treatment is effective in reducing the damage caused by a virus. 11 plants were randomly chosen. On each plant, 1 leaf was randomly selected, and the other half was left untouched. The amount of damage was assessed. This is a paired t-test because you're using the same exact thing on both sides. So a paired t-test because you're using the same on both sides. And yeah, let's actually do our free responses. So our free responses here, is there convincing evidence? We do need to make sure we always have our 4 parts to our convincing evidence situation, just in case you are coming in from somewhere else or you just weren't taking notes, you weren't paying attention. The 4 parts are always going to be the same. Part number 1, we want our hypotheses and parameters. Number 2, conditions. Number 3, run test. Don't forget to name it. And 4, conclusion. For these 2, context is required. Okay. Here we go. A study of adverse symptoms in users of over-the-counter pain relief medications assigned subjects at random to one of 2 common pain relievers, acetaminophen and ibuprofen. In all, 650 subjects took acetaminophen and 44 experienced some adverse symptoms. Of the 347 subjects who took ibuprofen, 49 had an adverse symptom. Is this convincing evidence that 2 pain relievers who experience adverse symptoms? So first of all, let's do our parameters first. We're going to go ahead and say that let P1 be the proportion of let's title this OTC. If you do that on your AP test, that's okay, by the way, as long as it's somewhere on the page that's clearly marked. So the proportion of OTC users who experience AS, adverse symptoms. Oh yeah, we're going lazy here. And we're gonna say let P2 OTC users of with ibuprofen, acetaminophen. Acetaminophen. This is the hardest part of the test for me, by the way, guys. All right, let P2 be the proportion of OTC users who experience AS with ibuprofen. For those who don't know, acetaminophen is Tylenol, ibuprofen is Advil. These are just those are the brand names, anyways. And our null hypotheses are going to be, our H naught is going to be that they are equal to each other, as usual the case with these. Sorry, guys. I apologize for all the mistakes I made today. Forgive me, for I have continued to be mistakings. And differ. Are they different? P1 minus P2 is not equal to 0. I've done part 1. Okay, nice. Let's do part 2. Conditions. So your conditions for these ones are your simple random sample for all of these random, and you could simply say the same exact thing on all of these SRS stated. That is fine. You do not need a complete sentence or anything fancy with that. It needs to be stated somewhere in the question, and it was. Yeah, it was randomly assigned. So number 2, you need to check your independence condition, and your independence condition is the 10% condition. So independence / 10%, independence / 10%, whichever one you want to call it. AP test accepts both. I write both down to show that I know what I'm talking about. The 10% condition is the fact there are 650 times 10 equals 6,500, and let's see, 347 times 10 equals 3470. Reasonable. It is reasonable to assume more than 6,500 users of both ibuprofen and acetaminophen. I'm just going to write ACE. I'm done. All right. If you want to write the entire acetaminophen out, you can. I'm sure the AP test graders would agree that it's just a lot of writing there. And our very last one is our large counts / normality. Remember, on the means situation, proportion situation, you call it the central limit theorem / normality instead of large counts. But in this one, we also need to do our n1 times p1 equals, we're going to need to do n2 times p2 equals, we're going to need to do n1 times 1 minus p1 equals, and n2 times 1 minus P2 equals. All 4 of those must be bigger than 10. And remember, the N1 times P1 is simply equal to quote unquote X1 on the original. So just in case anyone has been confused in class when I've been doing that, I've always been saying that our proportion is always equal to our successes over our total. So if I just multiply the N times the P, N times P is equal to X. And what that's talking about is, up here in the question, they already told us that 6 of the 650, which is our acetaminophen, or P1, 44 experience an adverse symptom. So that means that this right here is 44 right away. Likewise, the other one is 49 right away. And then they have to total up to the total of the situation, the 650. So this 44, I'm going to be doing 650 minus the 44, and that's going to be 606. And this one's going to be the 347 minus the 49, which is 298. Regardless, all bigger than 10. And so normality of the sampling distribution can be assumed. And that is the fanciest way of saying it. Probably don't even need to say all those words. Regardless, we did it. Number 3. I'm sorry for kind of going like a weird 1, 2, 3, not really a fancy order here. Step number 3, we have to run the test with the correct name. This is called a two proportion Z test. You can also call it a 2-sample z-test on population proportion, like I did earlier in the video. So we have a 2-proportion z-test, and the 2-proportion z-test has our z formula. We're going to write down exactly the same formulas we did before. As a reminder, this doesn't technically need to be written down, but it's a good habit to get into. And because, yeah, it's just a good habit to get into. So that's what we're going to do. We're going to go P1 hat minus P2 hat minus 0 divided by our big, huge square roots. And I'm going to use the one from the AP test instead of the one that I remember. So 1 minus PC, there it is. And then 1 over N1 plus 1 over N2, where PC hat equals x1 plus x2 over n1 plus n2. Okay, we do have to show what this is. And we should probably plug in those numbers somewhere, and then we're going to run the whole test in the calculator. So our x1 plus x2 is just 44 plus 49, and that's 93. And our n1 plus n2 is 650 plus 347. Okay. And I guess we should write down somewhere what all these numbers are, just so we have it. So we have P1 hat is equal to 44 over 650. P2 hat is equal to 49 over 347. And this right there is our N1, and this right there is our N2, just the bottom part of that. That's probably good enough. We could finally figure out what our z-score is and our p-value on our calculators. Don't forget, when you're running a means one, you have to do degrees of freedom. I don't know why I said that, because I bet you the next question I put on here was a means problem. That's what I normally do. All right, so now we're going to run our 2-proportion z-test. We're going to go tests 2-proportion z-test. And our z value, our x1, we just wrote that down somewhere, right? Right? 44? Yeah. So we got 44. Our n1 is, our sample size is 650. Our x2 is 49, and our sample size was 347. And this was a not equal to. That was our assumption was they are not equal, or our alternative hypothesis, sorry, and we're calculating it, and it tells us our z value is negative 3.8. Our p value is very close to 0. That's 0.00001, so there's a single 1 in that 4th decimal point. That's what that e to the negative 4 is. And by the way, this p hat they're giving, that 0.93, that's what this PC is. That 93 over 99.7 is that 0.93, so it gives it to us in the calculator just in case we wanted to write it down from that perspective. Oh my gosh, we needed to write those numbers down. And now I got to type everything in again. Guys, we're going nuts. Our z value is negative 3.802. 3 decimals, 4 decimals. Let's go 4 decimals. And our p-value here is 0.00, maybe approximate p-value, 0.0001. 4 decimals again. Beautiful. And finally, part 4. Because p equal 0.001 is less than alpha equal 0.05, we reject H naught. There is a reason to believe there's a difference. There is a difference in AS, adverse symptoms of OTC, ibuprofen, and acetaminophen. I'm lazying out here at the end. On the actual AP test, you probably should not lazy out and do it for real. But you know what? I'm okay getting a 4 on my video. Okay. Our last question, number 19. We're almost done, guys. How long have you had to watch this? 50 minutes. That's okay. That's acceptable. It's usually 60 minutes. So, well, 10-minute time limit. All right. Manager of a large company would like to know how much time new employees versus tenured employees spend on social media on their work computers during the day. He has a computer technician install software that logs the number of minutes spent on social media sites on work computers for random sample employees that have been with the company for a year or less, and a random sample employees that have been with the company for more than a year. Here are the results. The new employees use it a lot less than the tenured employees. With a bigger standard deviation too. So the new employees are afraid of getting fired, I guess. All right. What additional information you need to confirm the conditions for this test have been met? So, because you're assuming the conditions were met. Okay. So, the conditions are exactly the same, basically, as what we were doing here, where we have to have our simple random sample stated, our independence condition stated, and our normality. But like we said before, on this one, the normality doesn't count for large counts. We have to either know the sampling distribution is normal in advance, so we have to know that these things are normally distributed, or we have to have a dot plot or something that is showing no strong skewness or outliers. So let's do that. Letter A here. What else do we need? It's a large company. So large company is that 10% part. So so letter A, we need normality of sampling distribution for both samples by knowing normality in advance or a graph of the distributions of the samples. I'm gonna say just graph of the samples data. I'm gonna cross this distributions part off because it could be confusing to an AP reader if you put it that way. So we're just gonna say or a graph of the samples, a graph of yeah, the samples data. Let's put it that way. Showing no strong skewness or outliers. And this is normally done with a dot plot, histogram, normal probability plot. I don't know, whatever the heck plot you want to make. One of those two things has to be true. Letter B, same exact thing, but this time we're doing a confidence interval. So when we are doing that confidence interval and we want to make one up, they're going to ask for that T-star. They're going to ask for the degrees of freedom. They're going to ask for this. They're going to ask for that. You got to make sure we have everything written down. Let's do it. Same exact thing as before. You still have to check our conditions. We still have to state our parameters in context, all that kind of stuff. So but this one we don't have to make a condition, right? So let's just go ahead and say let mu1 be the mean number of minutes on, I'm sorry, SM for social media. Mean number of minutes on SM for new employees. And let mu2 and I should have just on the same line, so use my little dittos. be the mean number of minutes on SM for tenured employees. A 2 sample confidence interval for difference between mu1 and mu2, mu1 minus mu2 specifically, is given by, and we want to use that confidence interval formula. Yet again, on the AP test, it gives you the point estimate idea, gives you that confidence interval formula. Anyways, what we're going to be doing here is going to be x1 bar minus x2 bar plus or minus t star multiplied by our big, huge square roots s1 squared over n1 plus s2 squared over n2. Woof! All right. So I recommend throwing in all these formulas just to write it down and make sure you have it. But then afterwards, you are always able to use that calculator for it. So our x1 minus x2 is going to be 50 minus 0.25, 50.25 minus 89.57 plus or minus, and use the minus plus in the other one. And I'm going to skip t star for now because I am not leaving myself enough room to put it in when it does show up. But, you know, S1 was given to us in the question, by the way. That's where I got these two from. So we got 29.89 squared divided by 15 plus, and then we got 25.75 squared over 15. And this t star here, we are going to find this one by doing inverse t. So inverse t does have a degrees of freedom assumed. So we're going to go ahead and mess with that really quick. So we're going to inverse t. I don't know why I'm freaking out right now. I know where inverse t is. It's under vars, second vars. Inverse t right here. And you're going to have to input a degrees of freedom, right? So it does want a confidence interval. So our area is going to be our same 1 minus our confidence percentage, n parentheses over 2, which in this problem is 1 minus 0.99 over 2. And our degrees of freedom, couple different options you have here. The most conservative one is simply the smallest of n1 minus 1 and n2 minus 1. So in this one, I'm going to say 14, and that 14 came from smaller of n1 minus 1 or n2 minus 1. In this case, they're both the same. They're both 14. So we're going to do that. So we got 1 minus 0.99 n parentheses divided by 2. And our degrees of freedom here is 14. And we're going to get negative 2.976. So we have negative 2.976 in there. Now here's the deal. I'm going to go ahead and type in this entire thing, and I'm going to show you where these things all come from. But then we're going to notice the calculator is going to give a different answer on a different part of it. So we're going to type all this in, the whole dang thing, 50, I needed to do our whole parentheses, 50 minus 50.25 minus 89.57. We're going to start with the minus one. Actually, we'll start with the plus one. Oh yeah, we'll start with the minus. Minus, and the t star is going to be positive or negative. I don't know why I put the negative one in there, but it literally doesn't matter. 2.9 doesn't matter because you're doing both positive and negative, by the way. Square roots of a fraction 29.89 squared all divided by 15, and then plus alpha y equals enter 25.75 squared, all of that over 15. And we'll get negative 69. And then we're going to go ahead, which doesn't even make sense, by the way. It doesn't even make sense as an answer because it's, well, it does make sense. It's saying that they're 69 less minutes, which isn't possible if they only do whatever. Plus, and then negative 9. So those are our limits. It does make plenty of sense. Actually, I don't know why I said it doesn't make sense. It makes plenty of sense. I'm just a little bit on edge. All right. So this equals here negative 9.0049. There's our 4 decimals. To oh my gosh, 69 is a smaller number, guys. Negative 69 anyways. Negative 69.635 1 to negative 9.0049. So this is like our confidence interval. Probably should box that somewhere. But let's go ahead and do the problem. And I'm going to tell you right now that this is slightly wider than what the calculator is going to give us. Because the calculator is going to do a smarter degrees of freedom when it runs the 2 sample confidence intervals. So let's check that out. So we're going to go second, we're going to go stats, and we're going to go tests. And we're going to do our 2 sample is, where is it? 2 sample t interval, letter 0. 2 sample t interval. That's exactly what we called it. A 2 sample confidence interval for difference between these two. 2 sample z interval. And this time we're doing stat data. And our original was 50.25. Our standard deviation is 29.89. Our N1 was 15. These are all the numbers from the table, by the way, if you don't know where they're coming from. We got 25.75. Our N is 15 here. Our C level is 0.99. We never, ever hit pooled. And then we hit calculate. I wonder if it tells us degrees of freedom on there. So what you could do is, if you went through this entire thing, you could go back to figure out what you're at, what you want your answer. So this answer is acceptable if you wrote this degrees of freedom. But then if you did, I'm going to do it in blue this time. If you use the calculator, you're going to want to use the calculator's degrees of freedom for your finding your t-star. So this one is the degrees of freedom 14, but the calculator says that there's degrees of freedom of 27.399. So what you could do, I'm going to write the blue answer here. Maybe over here I'll write this. Or negative 67.51, negative 11.13. So like I'm saying, this is closer together. It's a little bit more squished because it's a little bit more exact because we have higher degrees of freedom. And those degrees of freedom, you could find, instead of negative 2.96, you'll find a slightly smaller number if you instead go and use that number I already forgot, that I forgot to write down. Thank goodness the calculator saves it. It didn't save it back in the day, I gotta tell you. If we use DF is 27.399. So maybe if you're actually on the AP test, you want to calculate this first, find out the degrees of freedom, and then use that to write your answer. But also remember, even if you don't put any of this stuff down, you can still get full credit if you just do this and then move on. But you do need to write those degrees of freedom somewhere. So make sure you write those degrees of freedom somewhere, and that you write the t-star somewhere. So both of those things have to be written somewhere with where you did it. Regardless, inverse t, and then degrees of freedom, if I change that to 27.3998 and then paste, you'll get the negative 2.76 in our thing there. So if I change that to a negative 2.76, so maybe just write this 2.76 76 using the DF of 27 0.3998. So if I do that and I go back to this one that I did earlier and I change this 2.967 and change it into 7676, so we need to change this to a 7 and then insert a 6. And if I change it there, you'll notice I get that same exact negative 11.13 that we did for this other one. regardless, that was a lot of talking for not that much situation. Anyways, I'm gonna use the blue one because I think that makes more sense. And we're gonna use, I guess I'll write it in blue. Our interpretation, we can be 99% confident that the true difference mu1 minus mu2 of the mu1 minus mu2 of the number of minutes spent on social media is between negative 67.51 minutes and negative 11.13 minutes. Those tenured employees are on their phones a bunch more, or social media a bunch more. Peace out, guys. I'm done talking. Have a great rest of your day.